comparing shadow interaction and diffraction patterns with laser beams and non-coplanar barriers. Here, we will examine two experiments. The first is a straightforward shadow experiment with perplexing factors obscuring either object along the optical axis. The second experiment involves diffraction caused by non-coplanar barriers, maintaining an aperture of 0.05 mm at the z=0 position. Stage first, outdoor shadows. In the first step of the experiment of shadows, the round-shaped obstacle is placed closer to the light source, and the square-shaped obstacle is placed closer to the screen. In the second step of the experiment of shadows, the round-shaped obstacle is closer to the screen, and the square-shaped obstacle is closer to the light source. The observed effect in the experiment of shadows is not attributable to the merging of penumbras. If it were, the result would resemble the image on the left, which has been created using Photoshop. In reality, the shadows of these two objects deform, as demonstrated in the image on the right. As depicted in this image, the shadow of the object closer to the screen stretches outward, while the shadow of the object closer to the light source is drawn inward.
In the first image on the right hand, the round-shaped obstacle is closer to the light source and the square-shaped obstacle is closer to the screen. In the second image on the right hand, the round-shaped obstacle is closer to the screen and the square-shaped obstacle is closer to the light source.
The result is much more obvious by squeezing on the y-axis. Stage second, diffused light shadows.
Using the diffused light as the source brings a similar result.
Stage third, diffraction caused by non-coplanar barriers. In this experiment, the left barrier is fixed and the right barrier is shifting forward and reverse. Furthermore, three lasers, a helium-neon laser at 632.8 nanometer, a diode laser at 532 nanometer, and a diode laser at 450 nanometer are employed.
In the first step, the beam splitters are set in a way so those three diffraction patterns stay above each other. And then the right barrier moves forward and reverse. As a result, the fringes on the left hand are getting more squeezed as the right barrier moves more forward, and the fringes on the right hand are getting stretched more, affecting the central band as well. Thus, the central band squeezes inboard from the left hand and stretches out on the right hand. In the second step, the beam splitters are set so the diffraction patterns overlay each other.
This effect can be explained easily by the geometrical analysis of diffraction based on fractal inhomogeneous space published at